Welcome back to the 4911 Cyberknights software training series. We had a bit of a break last time where I stopped teaching about Java and went through the process of setting up our machines for software development. Today we're going to get back into learning about Java, but we're going to do it through some of the tools that we installed. But before we get to that, let's go over what we went through in the previous session, not the install guides. If you want to know what to do there, just watch the install guides. But before that, we went through a number of things, including object-oriented concepts, talking about objects themselves and what make up objects, namely state and behavior. The state would be like the fields inside of the objects, those special types of variables, and then the behavior is contained within the methods. Those are the things that state is stuff that objects have, and then behavior is stuff that objects do. And then we talked about how to initialize an object, and the process that you go through is via constructors, special methods for creating objects. And then there was a concept called encapsulation, where we hide stuff inside the object, we encapsulate it, and we only expose access to it through controlled means like accessor methods. And then we went through and talked about instance methods and how there are roughly two different types: accessors, where you access the data, and then the other type of methods where you're modifying the data, and those are called mutator methods. And then we talked about the this keyword, which is kind of a annoying thing to talk about because this is a word that, well, it's just confusing, but this is a common keyword that you'll see a lot, so it's important to get it nailed down. And then we went through a lengthy code example. All right, so what are we going to talk about today? We're going to talk about using the IDE, the shiny new IDE that we installed, VS Code. In fact, it's a special version of VS Code, but we'll get to that. And then we'll talk about creating a robot program from scratch. And in the process of doing that, we're going to go through a couple of important concepts: inheritance and interfaces. And it's also essential to accomplish our task that we talk about third-party libraries. And we'll have an example, but the example isn't so much going to be at the end. It's going to be something that's sort of interwoven as we learn about all of these concepts. Okay, great. So what is an IDE? IDE, in case you're curious, stands for Integrated Development Environment, and it's a program for making programs, basically. And what it does is it assists you with common programming tasks. Some of those tasks are editing, compiling, bundling, which is not the same as compiling. Bundling is when you take all the stuff, all the source files that have already been compiled, and then maybe a bunch of other things, and you bundle it all together into a single program that gets deployed on the robot or on a computer, whatever you're programming for. IDEs are also helpful for testing your code. There's a special way of testing code without actually having to run it on a robot. And then debugging. We won't really go over testing or debugging today, but hopefully we'll get to those eventually at some point. IDEs often include things like wizards, just step-by-step guides that walk you through the process of doing tasks that are useful for whatever particular programming task you're doing. And they'll have like a bunch of other bells and whistles, typically, hopefully not missiles, and helpful stuff for doing what it is you want to do. Okay, so let's talk about our IDE. Our IDE is WPILib, the WPILib VS Code, actually. And if you did what I did and put it in a folder, put all your shortcuts in a folder, you can find it right there. Or if you pinned it to your start menu, you can launch it that way. It doesn't really matter. But when you first launch WPILib, you'll probably see a wizard. I've disabled it, but you'll see like a getting started page here. On the left-hand side, there's going to be these 5 vertical tabs. Most of the time, you'll be in Explorer, where you can see the contents of your project. I don't have a project open right now, so there's nothing to explore. There's a search tab where you can look through your code or other settings files for different things. Source control and running and debugging we'll go over probably in a future video. But the extensions tab is where you're going to see the different extensions that are installed for VS Code. By default, you should have WPILib installed, and I believe these other 4 extensions will also be installed if you've gone through the default process. At any rate, you can add other helpful extensions if you want, but keep in mind that sometimes they conflict with each other and it can cause issues. All right, so back to the Explore tab, and now we want to create a new project. And so we're going to open the command palette by tapping or holding down Control, Shift, and tapping P. All right, and so I'm going to type WPILib to get all of the WPILib commands, and there's a lot of them in here. We're not interested in all of them. All we're interested in is creating a new project, which I've done recently, so it shows up at the top of my list. You can just start typing create like that, and you should get the create new project. And it'll take you to, let me close that tab. Okay, it'll take you through this wizard or this project creator, and you can choose either an example or a template. I'm going to do a template. Our source language is Java, not C++. And I'm going to do a command robot skeleton. Okay, and what's our base folder? Let's create a new one. I'm going to call the project test project as well. And then you'll need to supply your team number. Now, down here, this last option, you can leave it unselected or select it. It's for enabling desktop support. Don't worry about this. Whatever you have it as, you can change it later if you discover that you need it. And we're not going to talk about that today. Generate your project, and it helpfully gives you the option to either open it in a new window or do nothing. I don't know why you would want to do nothing. It would be nice if you could open it in the current window, but it just doesn't give you that option. So let's open it in a new window, and then I will close that old window. Great. So we've got a new window. Every time you open a project for the first time, it'll warn you, like, the code in here is going to automatically execute. So don't do it if you don't know what the code is. I trust myself. I trust the other people who write software for our team. So I'm just going to click this box so I don't get the warning again for this project. All right. And you will see when this first launches, you'll see like a WPI-lib help. This is actually a really helpful link right here, the documentation page for WPI-lib. I would highly recommend opening that tab and bookmarking it. This is a really good place to remember. And what we're actually going to do is, this gives you a bunch of helpful guides on setting up your code and doing different tasks. But what I'm actually really interested in is the Java API docs. So I'm going to open that tab, and I'm going to come back to it in a minute. Let's go back to our code. Okay, so a bunch of stuff happened here down at the bottom. It actually went through and compiled all this stuff that was added to my project. And I'm not gonna force you to go through all these things, but what we're really interested in is this folder. And that's what these little chevrons pointing to the right are. They're folders within your current project. See, we have the Explorer tab open. So I'm gonna click the SRC, which is short for source. And within the source folder, there's another folder called main. And then within that, there's deploy in Java. Let's do deploy first. And deploy, well, the best way to know what deploy does is just to open the generated file that gets put in there, example.txt. And it tells you exactly what it does. Anything you put in the deploy folder will get bundled into your program, your robot program, and sent over to the RoboRio, which is the computer on your robot. So this is the deploy folder is for things that need to be on the robot but are not source files. So your source files may actually need to open other files, assets. Maybe it's going to be like auto paths, things like that get automatically, that need to be on your robot but aren't actually source code. I don't need this example.txt. In fact, a lot of teams, most teams probably, have the example.txt in their program, just always getting sent over to the robot. It won't hurt anything, but I think it's kind of annoying, so I'm gonna just delete it. Yeah, I don't want it. So now there's nothing in the deploy folder. But in the Java folder is for Java source files. We have a generated file structure. So within the Java, there's FRC. Within FRC, there's robots. And in that robot directory, there's these 3 different source files. So if you click them once, they open them. And then when you click away, if you click it once, it's more like a preview, and it'll be in italics. It's kind of small. Let's make the text bigger. Okay, so like I said, if you click them once, you get a preview. If you double click, then that italics go away, and then that file is now open. Whoops. I'm going to open all 3 of those and close the help tab. Okay, so let's kind of poke around in our code and figure out what exactly is going on. Let's begin with the first one, the main source file. So one thing you'll notice in here is that this method signature should stand out to you. Public static void main string, wait, ... that's a little confusing. Well, ... is basically the same as string array. string array args. So yeah, this is something we've been writing a lot. This is like the starting point of any Java program, almost any Java program. And your robot code starts at the same place, at this main method. And within your main method, whatever gets executed is the first thing that runs in your robot code. So this is a little confusing. We'll get to in a minute. But how does your first, before we get to that, let's ask another question. How does the RoboRio know that it should be this main method? Maybe you put a main method in robot.java. Why doesn't it run that one? If you're actually curious about this, you can go back to explore. Well, we can actually just search for main. Let's just do a search for main. Okay, and what you'll see, a lot of this Gradle W, don't worry about that. Manifest main.java, that makes sense. But the one that stands out here is this build.gradle. So I'm going to open build.gradle. Build.gradle, it has this robot main class defined, and it's actually giving you the package frc.robot.main with a capital M. Well, that is actually a reference to this source file or this class, because it's in the package frc.robot, and the name of this class is main. So it is telling the RoboRio that when you start running this program, start at this point, start in the main.java source file. And then when it gets to that point, it'll look for the main method in this main.java source file. This could be named anything. You could rename this whatever you want. And sometimes I like to, just because it's, I don't know, it makes you feel special, whatever. But as long as you update the reference here, then it will execute your main method. Okay, enough about that. Let's go back to the main method itself. This is where the confusion immediately kicks in. So what is RobotBase? If you want to know what something is in an IDE, you have an immediate option. You can just hover your mouse over it, and it will give you the documentation that's been written for that class. And so you can read this description in its entirety if you want to know what it is. But basically, the RobotBase is it's the base class that is going to be subclass, and we'll go over what that means, by you when you create a robot program. So when you create a robot program, you have to create something that subclasses RobotBase. And if you don't know what subclassing means, we're going to go over that. And then the rest of these are details that we don't really need to know about: overridden autonomous operator control, yada yada. We don't care. But if you really wanted to know all the nitty gritty about RobotBase, instead of just hovering your cursor over it, hold down the control button, and it'll highlight it like it's a web link, and then click it. Wow, okay, now we are looking at the actual source code. So if you ever want to know how something works, just command or control, I'm thinking about Mac, control click it, and you can see all of the dirty source code inside. So if you really want to know how RobotBase works, scroll all the way through this, read every line. We're not going to do that. There's like 450 some lines of code here. There's got to be a simpler way, and there is a simpler way. If you go to that tab that we opened earlier, this is the WPILib documentation for Java, and this is the RobotBase is a WPILib class. So that's where we need to find out about RobotBase. So RobotBase, when you click on that, it takes you to a page that has the written documentation. This is exactly what we saw when we moused over the RobotBase. But what we want to know is, like, what are the things inside of RobotBase? Well, there's a constructor, there's all these methods, and you can read through the entire thing. The documentation for a class will tell you the return type, it will tell you the name, and it'll give you a description. Sometimes the description isn't there, the documentation is incomplete, but very often it'll tell you exactly what that method represents, or what it'll return, what it does if you call it. And yeah, I guess that's as deep as I want to go for RobotBase. Let's go back to our code here. So if you remember, when you call, so this RobotBase dot, that means that this is not an instance method that we're calling, because it's not calling, like, if it was, if we had like a RobotBase, my RobotBase, whoops, and then like we created a new one, we'll just say equals null. That's not good. But so if you were to call my robot base dot start competition or dot whatever, then you're calling like an instance method on the my robot base instance of the robot base class. This is stuff we went over in the previous programming session, not the install guides, but the stuff before that. But if you don't have an actual instance, that means that this must be a static method. So let's go back to the documentation and look for the start robot method. So Control F, start robot. Okay, a start robot. And if we look to the left, yep, it is a static method. Okay. So start robot, it takes as its argument this thing that we've never seen before, and this is where things are going to get a little confusing, but it's okay. Just stick with me and we'll figure this out. Let's just read this little snippet to the right. This is the starting point for applications. Great. Okay, so that's what we wanted to know. Start robots, good. It's the starting point for your application, which is good because this is the main method is where your program starts executing. So it should start executing at the starting point. That's good. But what gets passed in? A supplier. I don't know what a supplier is, so let's click on it. I'm going to hold down Control so it opens in a new tab. And you'll notice when I open this one, supplier, this is not the WPI lib page anymore. This is the Oracle page. That means that this supplier is it's a class that is built into Java. So yeah, it's just something that's defined elsewhere other than the WPI lib library. And a supplier is an extremely simple thing. It's not a class at all. In fact, it's an interface. And it has, if you scroll down, it has one method. The method is called get. It takes no arguments, and the description says that it gets a result. If we try to look over at the type is a capital T. We'll go over what that means in a minute. But this is an extremely simple interface. And you'll notice that there's no constructor defined here. Interfaces are like classes without any of the stuff inside. It's like if you were to erase all the things inside of a class, all of the method bodies, but you kept like the actual method names, the return types, and the input parameters, but you just didn't do anything inside the methods. And then that would be an interface. Interfaces are basically descriptions of what a class should do. An interface can't be created. An interface is something that a class can implement. So if you have an interface like supplier and you want to create a supplier, you can't just say new supplier. You have to like create something that then is that then adheres to the interface supplier. And let's do that. Let's go through the process of creating a class that implements this interface. Mostly because the syntax is really confusing and I don't want to go over it right now. So I go to Explorer. We'll put it in the same spot here. So we'll right click, new file. And I'm going to call this robot supplier because that's what we want to do. We want to supply a robot. Maybe you don't know it yet. Maybe I don't know it yet, but that's what we're going to do. So robot supplier. And this is going to be a class. But we want it to use the supplier interface. And when you use an interface, you implement it. So VS Code helpfully is suggesting if I type IM, I must mean that I'm implementing something. And I am. I implements. What does it implement? It implements supplier. Okay, so implement supplier, and it has a warning here. This is the really nice thing about IDEs is that it has like almost like a spell checker built in. So it has these red lines under things that are errors, it has yellow lines under things that are warnings. And it does this live as you're typing. It'll tell you your mistakes as you're making them, which it can be like nerve-wracking, but it's also really helpful. So what kind of supplier? It says it represents what's the problem here? It says supplier is a raw type. References to generic type supplier T should be parameterized. Okay, so that's what the brackets, that's what this less than and greater than means. That means that supplier is parameterized. When you have a supplier, it is supplying something, and you have to say what it's supplying, and that's what you put in between that less than and greater than. So what are we supplying? We are supplying we're supplying a robot base. Remember how in the main method, when you start robot, it needs to, we should just go back to the documentation in the tab. So robot base, so start robot. It takes a supplier, the type of the supplier, it's the supplier of type T. But over here on the left, it says that your T has to extend RobotBase. So it has to be some sort of a robot base. And we'll go over extending RobotBase in a minute. But for now, let's go back to our robot supplier. We've got a couple of issues here. First of all, it says that RobotBase cannot be resolved to a type. Oh, well, that's pretty simple. That's because I haven't imported it. I can type out the import statement here, or I can mouse over it and click Quick Fix and import RobotBase. Haha, I've just saved myself a lot of typing. IDEs are awesome. Why didn't I do this before? Another thing that you notice about IDEs is that they have syntax highlighting. See how some of these words are dark blue and some of them are this teal color? Well, that's super helpful. The teal color and the dark blue help me to know that there's something different about those things. All right, let's go to our other error here. It says robot supplier must implement the inherited abstract method. Supplier robotbase.get Java. Okay, well, I'm not exactly sure what that means, but I do know if I look at the supplier, the supplier documentation, that I have to have this get method. So let's create our get method. We'll make it public. What am I getting? Well, the return type for get has to be whatever your parameter type or whatever your parameterized type is here. So it's going to be a robot base. Public robot base is my return type. The method name is just get, no input parameters. And then I have a left curly brace and a right curly brace. I thought I was getting somewhere. Well, I guess that error went away, but now I have another one. Okay, what's the error here? This method must return a result of the type robot base. Oh, wow, that's pretty obvious. I'm not returning anything. So what's my robot base? Well, I don't know how to create a robot base. So let's go back to the main method and see how they're doing it. Start robot new. I don't know what that means, but I know it has something to do with this robot class. Let's open the robot class. Oh, okay. So this is interesting. Now we need to talk about like inheritance. So we already talked about interfaces and how you implement an interface. There's another keyword that instead of implements called extends. You can implement an interface and you can extend a class. And that basically means that you are creating this sort of tree or more like a hierarchy. So a robot, this class that's created here in our project, it extends the timed robot class. And the timed robot class is something that is in the WP-lib framework here. You can see it if I mouse over it, or you can just see it in the import statements. So this is not part of our project. This is part of the framework. Robot, on the other hand, is part of our project. That's our package. So what is, but it says in the main, or in the robot base, it says that this thing that gets passed in has to be a robot base, and timed robot is not robot base, right? Well, let's check it out. I'm going to do the same trick I did before. Hold down Control, click timed robot. Okay. This is source code, so this is super secret, but you can look through it. So this is something that's built into the library again. Timed robot. Guess what? It also extends something. It extends this thing called iterative robot base. I don't really know what that is. Let's Control click it. Okay, so this is also a class. I don't know what abstract means. Let's just ignore it for now, pretend it doesn't exist. But extends. Okay, so it extends robot base. Okay, so now we have the full picture. So robot extends timed robot. Timed robot extends iterative robot base. Iterative robot base extends robot base. So that means that by if you think about math, by the transitive property, that robot extends robot base. And that must mean that in our robot supplier, we can return that robot class. Return, well, to create a new one, we have to use the constructor syntax new robot. And look, it says no more errors. So even though the return type here says robot base, we're allowed to return robot because robot can satisfy that. It extends through the transitive property. And this chain sometimes can be more than 3 classes long. It might be 7 or something. So robot does satisfy the requirement that it is a robot base because it's a timed robot. Again, timed robot is iterative robot base, and then that iterative robot base is a robot base. Okay, let's bail out of those things. Those are confusing, and get back to our robot supplier. Cool. So now we have a robot supplier. I'll delete this blank line. It is something that returns a robot base, and it says in the code for robot base, if I go back to the documentation, that it needs to have a supplier of type T, where T is extends robot base. Okay, so we have a supplier that returns a robot base when we call get, and let's pass that in here instead of this robot : new. So we'll say new robot supplier. Excellent. So yeah, we have now created a robot supplier. And now why did I do that? Well, it was an educational experience because in reality, robot base start robots, that previous syntax that we saw where it was like a robot : new. This is a method reference. And what that means is you can tune out this because it's not entirely necessary. But anytime you see this : syntax, that means that what we're actually passing into this start robot method is a reference to the constructor for robot. And that means that it will use the constructor, it will call the constructor. It creates a supplier basically that calls the constructor. It's a shortcut to do what we did by creating our own class. But I don't necessarily like leaping to shortcuts unless you're really comfortable with them. So let's do it the hard way where we really understand what's going on. And this isn't that hard of a class to write anyways. It's a little verbose. This is this is what you call boilerplate. It's code that there's a lot of code in here that doesn't really do much. The only code in here that really does anything is this single line right here. But still, for clarity's sake, and because we're relatively new to this, let's prefer this syntax over the method reference. Okay, so what we have now is a main class with a main method that starts up our robots, or that passes in our robot supplier, and our robot supplier creates a new robot object. Okay, so we've got those squared away. I'm going to close those. I'm going to close the build.gradle tab. And now let's look at our robot class. This was something that was generated for us when we created our project. This thing extends timed robot. We talked about that, but when you extend something, that means that you are subclassing it, or you are a subclass of it. It is your super class. So sub means below, super means over. So the robot, because it extends timed robot, it is below robot. That's why robot is a subclass. In fact, let's rename this. Because it's a little confusing, I'm gonna just highlight robot and press the F2 key to go through the renaming process. This is way easier than trying to rename it everywhere. This is where IDEs really shine. And let's call this class the Cyber Robot, because it's the Cyberknights robot. In fact, we'll just call it the Cyberknights robot. I feel like that's a little bit more clear about what's going on, because this is our class. This is not something that's built into the WPI lib. Great, so now we have that. It's been renamed. And what happens inside here? Well, inside this, because it subclasses timed robot, we can now override the parent class's methods. So that's what this override annotation, that's what every time you see this @ sign, that means that this is an annotation. This is not actually code. This is what's called metadata. This describes what the code is doing. So when you are overriding a method from a parent class, you need to put this annotation in as a signal to the compiler that this is a method that overrides another one. And the reason why is that if you say like robot init and you do a typo like init, then it will say, well, it must override or implement a super type. So yeah, that means that this isn't overriding anything because there's nothing in the parent called robot init. But if you accidentally left off that override, suddenly the error goes away because Java is not smart enough to know that you made a typo here. It just trusts that you are doing the right thing. So that's why it's important to keep your override annotations in. Okay, so helpfully, when you create a new project, the robot class that's generated will plug into these override methods and do the right thing. In general, you don't need to really do anything in your robot class unless you're getting pretty advanced. But you can kind of look through these method names because they're really helpful to understand. So robot init. You can mouse over it and get the documentation for robot init, what robot init does, but you can kind of know what it does just by its name. This is really well named code. This is almost self-documenting. So robot init, we would assume that it means that this code gets run when the robot is initialized. And if you mouse over it, yeah, robot wide initialization code should go here. Okay, cool. Robot periodic, what does that mean? Well, periodic is something that has a period, it means that it goes in cycles, it repeats. So I'm guessing that this robot periodic method is something that gets run over and over again while the robot's operating. Let's mouse over. So it's periodic code for all robot modes should go here. So yeah, that's periodic code. Disabled init. So when I would say that probably means when the robot is disabled for the first time, or when it first enters the disabled state, this method would get called. Okay, and then these are all similarly named. There's disabled periodic when your robot's disabled. This runs periodically. When you are leaving this disabled state, this method will execute, and the same for these other states. Autonomous. When your robot goes into the autonomous mode, this method gets called. And then during the autonomous mode, this method will get called over and over again. When you leave it, this method will get called, and the same for teleop period. There's also these ones for test init, test periodic, and test exit. We're not going to worry about those. But yeah, this is all we're going to do for the robot class. We're done with the robot class. We're not going to do any changes in there at all. Goodbye. Okay, robot container. What is a robot container? Well, a robot container is something that's generated for you. This is where you generally want to put your actual code, the things that get set up. So when your robot first gets started, when your robot gets initialized, the robot container is created. I guess I closed the Cyberknights robot a little early. When does robot container get created? In robot init. Okay, so that's all we need to know. When the robot is initialized, this gets created. We have this configure bindings method, which is currently blank. And we're going to, this is basically where you're going to put button and stick bindings here. So if you have a Xbox controller or a joystick or whatever, you're going to bind those buttons and sticks to different actions here. And then this get autonomous command. This is just a method that gets called when you enter the autonomous mode. Right now it has this line of code that doesn't really do anything except print out to the console that there's no autonomous command. Super helpful. Okay, so that's it for now. Let's move on to something else. Okay, so what we're going to do now is we're going to bring this robot back to life. This is Merlin. Merlin was the Cyberknights 2016 competition robot. It's seen better days, it's been beat up, but it's still a good robot, and we can still learn a lot by using it. What we're going to do is we're going to make it drive around. And what we need to do is figure out which motors on this robot are responsible for driving. If we look underneath the robot, we can see that on each side, it's been pretty beat up, but there's two robots here, or two motors on one side of the robot, and two motors on the other side. So those must be the drive motors. They're connected to the gearboxes, which are then connected to the wheels. And the wires for these motors come over here and connect to our motor controllers. We may have to really fiddle around with the wires, but it looks like on this side, the controllers are 10 and 12. And on the other side, I believe the ones that are hooked up are 7 and 9. Okay, so thinking that this is the front of our robot, it sounds like 7 and 9 are going to be the left-hand motors, and then 10 and 12 are going to be the right-hand motors. We'll remember those numbers when we get back to our code. Okay, back to our code. So what we need to do now is write some code that will control all the aspects of driving the robot. And logically, the way we break these down, these things down conceptually, is that we call them subsystems. You'll have like a subsystem for maybe an arm, a subsystem for a collector, a subsystem for all different things on your robot. And we're going to create a subsystem for the driving. The nice thing about WPILib is that it actually has a framework for representing your subsystems. So let's go to our Explorer tab, and we will create a new file. And we're going to call this thing the drive subsystem. And yes, it's a class, but it needs to extend. Well, we'll get to it in a second. So let's go back to the WPILib documentation, and we will type in subsystem. So subsystem, great. Subsystems, you can read through this entire documentation, but it's a basic unit of robot organization. And we're going to send commands to different subsystems, or rather, I guess commands are going to use different subsystems. We are going to, this is a little confusing because this is an interface, and we don't want to use the interface. We want to use an actual abstract class. In the next iteration of the WPILib, it's currently preview. I believe they've replaced all these interfaces with the actual abstract classes. So by the time you're reading this, this may be obsolete. This interface may not even exist anymore. And this abstract class called subsystem base is probably going to be renamed just subsystem. At any rate, this is what we're going to extend with our drive subsystem. All right, so let's go back to our code, and we will say this thing extends the subsystem base. All right, and what that means is that when you extend something, that means that you get all of that thing's functionality. So there's code in this subsystem class that we get for free. Scrolling through here, there's a bunch of stuff that maybe we don't understand, but all of this code runs when we're running our drive subsystem. We get that for free because we are extending it. So let's use let's put our motor IDs in here. And because they're constants, let's make them constant. So we'll just call them, these are ints. These are the IDs for our motors are integer numbers, they're whole numbers. And so we'll say left motor 1, or we'll just say 1. I believe on the left-hand side, those were, I forgot them already. I think the left ones were 7 and 9. Left motor 2 is going to be 9. And then we'll copy and paste just because we're lazy. And here's another trick that Visual Studio allows you to do. If you hold down the Alt key, you can actually place a second cursor. And now when you type, it goes into both those places. So ta-da! Okay, and the ones on that side, we have 7 and 9 on the left-hand side. On the right-hand side, we had 10 and 12. I believe it skipped 11. Okay, so those are our motor IDs. And now in our subsystem, we're also going to want to create the motor controllers themselves. And these particular motor controllers are Talon SRXs. And we're going to run into a problem right now. So if I just create a constructor, so we'll say public drive subsystem, and I'm just going to try to create a new Talon motor controller. So we'll say WPI Talon SRX equals new WPI Talon SRX. And I know that the constructor for this just takes a, just takes a number. So I'm gonna say, I'll do the left motor one. So I'll say a left motor controller 1. Now, I know these classes exist, but they can't be resolved. And if I try to do the whole like quick fix thing, it's going to say create this class. No, I don't want to create it. I know it already exists. So right now it's time to comment this out. We'll get back to it in a second. We need to bring in a third-party library. So the way that we're going to do that is through the command palette. So you can either just click the icon up here, or I think I said it was Command Shift P. Yeah, okay. So we're going to manage vendor libraries, or I think you can just start typing libraries and it'll autocomplete. And we don't want to check for updates. We want to install new libraries. We're going to say offline. And these are the Talon motor controllers are in the across the road electronics libraries for Phoenix. We'll use version 5. And it'll give you like a warning. So after you add these libraries, you should rebuild your project. Okay, it's recommended. Let's just do it. It's recommended. You'll see a bunch of stuff happening in the terminal. And build is successful. Let's try uncommenting our code and see what happens there. And at this point, I mouse over my error again. Whoops. Click Quick Fix, import Talon SRX. It's just that easy. Wow. Okay, so now I have the WPI Talon SRX classes. So that's how you can use third-party libraries. So that is a library that CTRE library is something that doesn't come with WPI lib. It's something that I showed you how to install the Phoenix tools in a previous video. But once they're installed, you can use the command palette to add that library as a dependency to your project. And if you're not using the CTRE components, you may have to add a different library to use your particular motor controllers or whatever it is you're trying to do. At any rate, we've got a bunch of these to create. I don't want to just create the motor controllers in the constructor. I actually want them to be fields in this drive subsystem class. So let's create a private and there we go. And now I'm going to duplicate that because we have 4 motors to do. Whoops. And let's do a quick check just to make sure everything makes sense. Left motor controller 1, left motor 1, left motor controller 2, left motor 2, right motor controller 1, right motor 1, right motor controller 2, right motor 2. Okay, that's sanity check. Everything is good. So now we have created these motor controllers. So what we want to do now is create some motor control groups. And this is a class that's built into the the WPI lib or the WPI lib library. So we can either like look for it, or we can just start typing. And if you know the name of the class, then you can use the quick fix to import it. So we'll say motor controller group will left equals new motor controller group. And this motor controller group, we're able to like pass in multiple motor controllers. So we're going to pass in, since it's the left-hand side, we're going to pass in left motor controller 1, and we're going to pass in left motor controller 2. Great. So that covers the left-hand side. Now we want to cover the right-hand side. Cool. So now we have the left and the right. And now what we want to do is create a differential drive system, or a differential drive using these 2 motor controller groups. A differential drive is, well, it's exactly what we're doing. It's tank drive. It's something where all the motors on one, or all the wheels on one side are going one speed, and all the motors on the other side are going the same speed if you want the robot to go forward, or they may be going a different speed if you want the robot to turn. And so let's create a field up here for it. And it's just called differential drive. You can see it show up at the top of my autocomplete, so I hit enter, and we'll call it differential drive with a lowercase d. And now let's instantiate that. And it automatically will, it wants me to pass in the left as a first argument and the right motor control group as the second argument. So it automatically did that for me. Great, awesome. So now we have a differential drive. So everything should be great. Everything is awesome. Our robot doesn't do anything, but let's try sending our code over to the robot. Okay, so now I've switched Merlin on, and I've gone through the process of connecting to Merlin's radio through my Wi-Fi, and annoyingly, you have to turn off your firewall settings. It's not great, but the software just doesn't seem to play well with firewalls. Make sure to turn your firewall back on when you're done with this. Okay, so what are we going to do? We are going to build this and send it over to the robot. And you can do this by clicking deploy, or clicking the command palette and finding the WPILib deploy robot code option. And when you do that, you'll see a bunch of activity in the terminal. It'll build your code into an application. It will send it over Wi-Fi to the waiting robot's RoboRio computer, and then it will begin executing. And right before it begins executing, or I guess as it begins executing, it's going to open a tab or a second pane in your IDE for the log. And in the log, you'll see the output of your robot's code. Okay, so at this point, I need to launch Driver Station. It should be in your FRC stuff folder, or you can just look for it in the start menu. Driver Station will also launch like this, maybe this thing called Shuffleboard or something else. I'm just going to get rid of it for now. Okay, so Driver Station is an important tool that runs on your computer, and it manages the connection between your computer and the robot. Going back to our IDE, you can see that the Rio log is now populated. It's like outputting stuff. How do we know if our code worked? Well, our code doesn't really do anything. Let's make it do something. Up until this point, like a lot of the time, we've just used system.out.println. So let's just do that. Let's go to our robot container, and in the constructor, we'll just print a helpful message, and we'll say, it's working. And then in our drive subsystem, we'll say, now this is pod racing. Okay, and we will redeploy our code. It should be at the top of our options since I just did it. Okay, and I'm going to pause here because I think I saw our message, but let's scroll back. Okay, there's our message. It's working. Robot program startup complete. Now we didn't get our now this is pod racing message, but that's actually understandable. I'm going to close the Rio log for now. That's actually understandable, and that is because our drive subsystem has not been actually instantiated. Let's actually create our drive subsystem in the robot container, because we know our robot is going to want to drive, so we've got to create a drive subsystem. And we will instantiate it. We'll populate that instance field, drive subsystem, on startup. Redeploy. Now, there's a shortcut key for deploying. You can just click Shift F5 if you want to be like elite. the Rio log will automatically relaunch. It remembers that I paused the logger, so it's not showing me anything. So I'll unpause it. I don't know what it needs me to click it twice, but it does. All right, so there's our message. It's working. Now this is pod racing. Great. Okay, everything's awesome. Let's go back to the driver station. Driver station has a number of options here. It allows you to change what mode the robot is in. By default, it should go to teleop. You can enable the robot and disable it. Our policy when you enable a robot is to make sure you shout loudly the word enabling so that everyone around you knows to watch out, and to carefully stay at the computer in case your code does something bad and the robot shoots off sideways or maybe does something that might rip itself to pieces. And just be careful and stay by your computer. Once the robot is enabled, you can tap the space bar to disable it in an emergency. You don't have to like move your cursor down to the disable button. If you panic, just hit the space bar. You can go into autonomous mode, and then there's these other modes. Helpfully, it shows you how much voltage is on your battery. If your voltage drops too far, things will start flaking out. So monitor that. You want to keep it around 12 or keep it higher than 12 generally. These little light up, they look like LEDs. They indicate what's good and what's bad. Right now, we have communication with the RoboRio. The RoboRio is running the robot code. However, there are no joysticks, and that's because I don't have a controller hooked up to my computer. I will hook up a controller to my computer, but I'm not actually going to use it yet. Let me grab that Xbox controller. Now, I'm about to plug this into my computer. If we're fortunate, it'll just start working immediately. It doesn't always work immediately. Sometimes you have to like refresh here. If you plug in your controller and it doesn't work, you just click rescan until it does. Driver station can be a little flaky, but now we have 3 greens, so everything's ready. In fact, I can move the sticks around and see like, oh, well, yeah, things are like the inputs are changing. If I tap buttons, inputs are going. Everything's good. We're great. Let's get back to our subsystem and actually try to drive this computer or drive this robot around. In order to drive the robot around, I'm going to have to learn about this differential drive class. So I can either mouse over it, I can control click it if I want all the gory details, or I can go to the website. Now this is where things get a little bit annoying because I'm on the wrong Wi-Fi if I try to go to the website and type in a differential drive. I'm going to get an error because the Wi-Fi, the radio on the robot is not connected to the internet. So I'm just going to click back and forth. It's kind of tedious. Okay, differential drive. So what do I want to do? I know how to create a differential drive. I've already done that. I added the left, I added the right. Now, when I create a differential drive, I want to drive at some point. And how do I want to do that? I want to use this thing called arcade drive. Arcade drive method for differential drive platform. Let's click on it. And what are these different parameters that I'm passing in? X speed is the robot's speed along the X axis, -1 to 1. The benefit here of it being -1 to 1 is that when you have joysticks, or when you're reading the joystick inputs from a controller, they also go from -1 to 1. So if I want to map like the left joysticks like Y components, you think about like you push forward on the left joystick, the robot goes forward. You pull it back, the robot backs up. That'll work perfectly here. And then Z rotation is like the robot turning. So if you think about like the right joystick, I probably would turn. I don't think I want to map both these to the same joystick. That might be a little funky. I'm going to use the right joystick on my Xbox controller to handle rotation. So pushing left should make the robot turn left. Pushing right should make the robot turn right. Okay, so that's the method that I want to use, arcade drive. I don't think I can continue reading the documentation. There's a few other things I can do, but let's just use arcade drive. It seems simple. So in my drive subsystem, I want to expose a method, public void drive the robot. And in here, I want to my differential drive, call that arcade drive. And This time, VS Code isn't all that helpful. It's trying to match in these parameters that are not really appropriate. These are constants. I don't want to use those. I want to have like an X speed and a Z rotation. So those are, if I go back to my documentation, those are going to be doubles. In fact, I can just like copy and paste if I'm feeling super lazy. X drive and Z rotation, or X speed. Z rotation. Great. Yeah, so now from the robot container, I want to, in this method, configure the stick bindings. I want to bind my Xbox controller to the drive subsystem. So what I'm going to do now is I'm going to use a command. Hopefully WPILib has this command framework, and it's the relationship between commands and subsystems is that your subsystems represent like a component on your robot, and a command is something that your robot does. So I'm going to create a drive command, and this drive command is going to be a command that just runs all the time during teleop, and it's going to be reading the controller and sending the controller's current inputs to the drive subsystem. We've already created a way to send values to the drive subsystem. Now we need to create a way to pass the controller's inputs. So let's go back to our robot container. We'll create the command in a second, but let's get our controller first. And we're going to use the Xbox, let's see if I can remember the name of it. I think it's called Xbox command. No, command. Well, we'll just try something. So I'll just start typing. This should be private as well. I'll just start typing Xbox and see what happens. Xbox controller, I don't want that. I want it to be a command. There we go, command Xbox controller. That's what I want. And I'll call it the driver controller. And in the same place where I create my drive subsystem, I want to create my driver controller object. And it will take a port. The ports, if you look at your USB inputs, they go from 0 to 5. So I want the first controller. I'm only going to plug in one controller. I want the first controller to be the driver controller. So that's why I'm going to use 0 here. Great. So now I have a command Xbox controller. That's fine. But now I need to create a command. So let's create a drive command. And drive command needs to extend command base. And the same thing I said about subsystem base and subsystem is going to be changing in the next version of WPILib. I believe that the command interface, if you go to the command source code, it implements this command interface. The interface is going to be deleted, and the command base class is going to be renamed command. All right, so anyways, in command base, we need to have the Xbox controller, and we also need to have the drive subsystem. So let's add those as parameters to our constructor. So we'll do the drive we'll do the Xbox, we'll do the controller first. And then we'll do the drive subsystem second. And we'll add those as fields to our class as well. And now we need to use this keyword because they're named the same. This dot controller equals controller. This dot drive subsystem equals drive subsystem. And now this is something that is kind of reviewed from the last programming session where, like, in order to disambiguate between these two things that are named the same, controller and controller, you have to use the this keyword. But one of the cool things about Visual Studio is that when you control click on one of these names, so this is not a class. If you control click on the class, it'll take you to the source code. We've seen that already. But if you control click on the name, it'll take you to like what it's referring to. So if I control click on this controller, it takes me to there. If I control click on this controller, it takes me to there. And so now you can see that these are two references to two different places. The same for the drive subsystem. And if you omitted this and did that error that we talked about previously, Visual Studio will warn you that this doesn't do anything. And furthermore, if you command click on or control click on these, it'll take you to the same one, letting you know that you are not actually writing to the drive subsystem that's in your drive command class. You're just overriding the parameter that was passed in, which literally has no effect. Okay, cool. So we have that. So now in our command, we want to do something over and over again. And the way that you do something over and over inside of a command is that you override a method. And you're going to override the execute method. So if I look in command base, there should be an execute method. Actually, it might not be in here. Yeah, I think it's going to be in the command interface, actually. There we go. So that's the one that we want to override. So it returns void, it takes no parameters, and it just says, it's just called execute. Public void execute takes no parameters. And now to tell the compiler and Visual Studio Code that we are overriding it, we're going to use the override annotation so that if we have a typo here, it'll give us that error that we talked about earlier. Okay, so over and over again, we want to read from the controller and we want to write to the subsystem. So how do we read from the controller? Well, let's try just doing some stuff. Controller dot. What do we have here? Well, we have a bunch of like A. That must be the A button. B is the B button. Back is the back button. So on and so forth. Get left X. Get left Y. Get right X. Get right Y. Now these are the actual. I can actually control click on them and it'll take you to the source code. Get the x-axis value of the left side of the controller. Oh, I want the y-axis value of the left side of the controller. I'm going to call this double forward backward. So that's the forward backward component. And then the other component is going to be the turning. And this time I want to get the controller's get right X. So I want to get the horizontal component of the right joystick. Then I want to pass both those things into the drive subsystem. So drive subsystem dot drive the robot forward back. Yeah, that's what I want. For the X speed and for the rotation, I'm going to pass in the turning. Cool. Okay, so I think that's good. Now there's a couple of things that we want to add here. I also want to override this other method called public void end. I think that's what it's called. Oh yeah, that's right. It's warning me like, yeah, the method end of drive must override or implement a supertype. It's because I've gotten it wrong. If I go back to the command interface, end actually takes a parameter, this Boolean interrupted that tells you whether the command was interrupted or canceled. So in order to properly override it, my signature has to match exactly. Okay, what do I want to do at the end? Well, I want to stop. So I want to drive the robot, but I want to set everything to 0. So if my command stops running, I want the robot to stop driving. I don't want to, like, if the command gets canceled, I want it to just keep going in the current direction it was already going. That could be bad. Okay, so now one more thing I want to do in this drive command. Commands use subsystems. And that the reason why that's important is that if you have two different types of commands, or even two different commands, two different like instances of the same command that are both trying to use the same subsystem, you can have big problems because one command might be like telling the motors to do one thing, the other command is telling the motors to do another. Who wins? Well, the way to tell who wins is to use this add requirements method. This add requirements method is something that lives inside command base. So we get it for free. We're extending command base in our drive command. So we can just use this method as if it's ours because it exists. It gets copied into our class when we extend it. And our requirement is going to be all of the subsystems that we are using in this command. This subsystem only uses, or this command only uses the drive subsystem. So what this means is now when this drive command starts executing, it is going to like basically call dibs on the drive subsystem. So no one else, as long as this current drive command is running, no one else gets to touch the drive subsystem until it completes. And that helps to resolve the conflicts. Okay, so I think that is complete. So we have a drive command, but now what we need to do is we need to set this as the default command on our drive subsystem. So let's go drive subsystem set default command, and we don't want to use get autonomous commands. It's not always helpful. New drive command. And helpful, okay, VS Code, you did the right thing, great. So drive command takes a controller and it takes a subsystem. It takes a drive subsystem. So we only have one controller and we only have one drive subsystem. That's great. So now this is our default command for the drive subsystem to just drive. Sounds good so far, but is there anything we're missing? I think we're okay. Let's try running this and see what happens. I don't know, actually, I don't know if I went over this. Okay, set default command. The reason why I can call set default command, even though in the drive subsystem, I don't have a method. Like if I search in here, set default, there's no set default command. There's no matches. Set default, no matches. There is no set default command on the drive subsystem. That is the reason why I'm allowed to call set default command, even though that method doesn't seem to exist, is that I have inherited it from subsystem.class. So you get to inherit class or inherit methods. Okay, so now we should be able to deploy our robot code. Let's go back to our driver substation. You see the robot code goes red for a moment while it's installing and restarting. Communication is good. And okay, great. Everything's running. Now my inputs, if I go to the USB tab here, I can see my inputs are working, but the robot's not doing anything because I haven't enabled. So I'm going to enable. I'm alone in the lab, but I'm going to say the word anyways. Enabling. And now I'm going to try driving the robot. Okay, I want to show you what's happening here. You couldn't really see it from the screen capture, but I'm going to show you what's happening. So on the left-hand side, I have this thumbstick. When I push it forward, the robot should go forward, right? So it looks like the robot's turning. If I push it back, the robot should go back. It's rotating the other direction. And now, conversely, if I try to turn the robot using the left thumbstick, or the right thumbstick, okay, it's going back and it's going forward. So you might think that what I've done here is I've reversed like the thumbsticks, but I haven't. I have made a mistake. I made a very different mistake. And the mistake that I've actually made is that when I set up all my motors, I forgot to account for the fact that the motors on one side face one way and the motors on the other face the other way. So I need to make sure that I reverse when I set up my motor controllers. I need to say the motors on one side are reversed. Now, which ones should be reversed? Well, let's see here. Let's go over what actually happens with the controller. So if I go forward, let's see which side is actually going forward. It looks like the left-hand side is going forward. And if I go backward, the left-hand side is going backward. Okay, so I think the left-hand side motors are correct, and it's the ones on the right-hand side that I should set as reversed. Okay, so I'm going to close the real log for now. And now when I set up my drive subsystem, we said that the left-hand side is okay, and it's the right-hand side that's wrong. So if I go to this motor controller group, this is kind of annoying because I'm on the wrong Wi-Fi, so I'm just going to look through the source code here. So I'm going to look for the word inverted. Okay, and I have a method called setInverted. So I'm actually going to call that on the right controller, or the right motor control group. And I'm going to set it to true. So we'll invert the motors on the right-hand side, and hopefully that'll fix the problem. Let's redeploy and see what happens. Okay, here we are back again with Merlin, and those changes are now on the robot. So I'm gonna cross my fingers and push forward on the control stick and hope that it tries to run me over, because that's what I want it to do. Okay, so it's moving forward, and then when I push back, it should go back. Okay, great. Now the moment of truth. Let's see if the turning code actually works. It should go, if I go left, it should start rotating counterclockwise. Fantastic. And then if I go right, it should rotate clockwise. Excellent. Yeah, it looks like everything is exactly as I want it to be. Merlin is still viable. So as a quick review, what we went over today, we learned how to use this, the WPI-lib VS Code. We talked about how to create a new robot program. We even got it running on an older robot. We learned how to add third-party libraries to use these Talon motor controllers. And then we went through like the advanced concepts, like using these commands and how to use subsystems. And then we talked about things, kind of difficult concepts, but that are nonetheless really important, extending, what that means to extend another class and how you get all of its stuff for free. But we also talked about implementing, how you implement from an interface, and remembering that interfaces don't actually have code in them. They just sort of define what you're supposed to do, and you got to write it all yourself. So you don't get anything for free. It's more like homework. Yeah, and through the whole process, we did our example code. So yeah, fantastic. I'm really excited. Moving forward, we should do increasingly more advanced stuff. But that is the general idea, how to learn Java and how to get your robot code up and running on a robot. Thank you, and I'll talk to you later.